Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Qadir Hidayat bin Abdul Kahar, and for this topic, I want to present about prestressed concrete and where this method is applied to for the BSR 552. There are two methods of prestressing in concrete. First is pre-tensioning and second post-tensioning. So, what is post-tensioning? Post-tensioning is a method of reinforcing concrete or other materials with high-strength steel strengths called tendons. This kind of method is applied at structural members beam, bridge deck panels, roof slab, and concrete silos. There are many advantages from this method. For the first one is post-tensioning allows longer clear span, thinner slab, fewer beams, and more slender dramatic element. Second, thinner slab means less concrete is required. Third, post-tensioning can thus allow a significant reduction in building weight. Fourth, a lower building height can also translate to considerable savings in mechanical system and facade costs. Next, another advantage of post-tensioning is that beam and slab can be continuously from end of the building to the other, reduce occurrence of crack, and lastly, freezing and thawing durability is higher than non-prestressed concrete. There are many advantages from this method. So, how is this method being constructed in construction site? Instead of ground construction, unbound tendons are typically prefabricated at a plant and delivered to the construction site, ready to install. The tendons are laid out in the form in accordance with installation drawing deck. After the concrete is placed and has reached its required strength, usually between 3000 and 3500 psi, the tendons are stressed and adjusted. The tendons, like a rubber band, want to return to their original length but are prevented from doing so by the anchorage. The fact that tendons are kept in a permanently stressed state causes a compressive force to act to the concrete. The compression that results from the post-tensioning counteracts the tensile force created by subsequent applied loading. Example like cars, people, the weight of the beam itself when the shoring is removed. This significantly increases the load carrying capacity of the concrete. Since post-tension concrete is cast in a place at the job site, there is almost no limit to the shapes that can be formed. This kind of method also have their own limitation. The limitation of prestressed concrete are few and really depend only upon the imagination of the designer and term of this brief. The only real limitation where prestressing is a possible solution may be the cost of providing mode for runs of limited quality of small numbers of non-standard units. A system for applying tension to and occurring the end of a prestressing tendon extending from a concrete structure. The system includes a jack for applying tension to the tendon at a first location along the length. Thereof, anchoring means comprising an anchoring plate, and collar means dispose about the tendon and adapt more for movement into cooperation with the anchoring plate to grip the tendon located at a point on the tendon between the first location and the concrete structure. The case study that I choose is Frank Lloyd Wright's Falling Water, Mill Run, Pennsylvania. The lower and upper terrace cantilever over the stream below. The temporary structure, steel shoring, was placed beneath the main level of the terrace. So, the applications of my case study is Falling Water is comprised of a series of concrete cantilever trays for 30 feet above waterfall. Previous efforts failed to permanently address excessive deflection of the cantilever and repair the crack. After a thorough design review, the owner and the engineer select an external post-tensioning solution for its durability, chesthetic and structural unobtrusiveness. Construction plans call for strengthening the three support girders spanning in the north-south direction, with multi-strand post-tensioning tendons consisting of multiple 0.5 diameter strands. 13 strand tendons were placed on each side of two girders. One 10-strand tendon was placed on the western side of the third girders. Access on the eastern side of these girders was not available. 8 monostrand tendons of 0.6 diameter were selected for the east-west direction. The monostrand tendons were stressed in the east-west direction, and then the multi-strand tendon was stressed in the north-south direction and grouped with high-quality, low-bleed cementitious grout mixture. VSL scope of work also include welding steel cover plates, attaching structural steel channels, injecting epoxy grout dwelling reinforced case in a placed concrete blocks, and the installation of near-surface mount carbon fiber rods. Challenge with maintaining falling water's original setting, finishing, and artwork. The project was successfully complete in 6 months. These are the examples of the equipment used at my case study.